Hi everyone, good morning. It's good to be here. Glad to see so many of you here after last night. That's awesome. I'm going to fly through this talk, getting functional with fab. Unless you are a German speaker, then I guess this would be the title. Unless you are a German JavaScripter, in which case this would be the title. So hopefully that should educate you on where we're going here. Getting functional with fab. My name is Schmidt. Yeah, name is German, but that's where it ends. My dad's dad is German. That's an awkward conversation here a lot, so that's been fun. I'm a hobbyist programmer. I actually translate computer manuals for a living. So most of my language stuff is natural, but I really do enjoy programming, and I have a kind of a weird flavor that I'd like to share with you. I love functions. Do you guys love functions? Functions are seriously awesome. They're the best part of JavaScript. Do you think does Node love functions? Yeah? All right, fire up Node. And type that. Guess what? It doesn't. I mean, Brian, are you here? Because seriously, that is a WTF. But seriously, basically, I think, we've heard that, like, JavaScript is, the father is C and the mother is scheme, and, Brennan Eich is the midwife, I guess. And so it's really, a lot of the C parts of it are in there. But there's not a lot of scheme. I like the scheme parts, and so we're going to talk about that. I'm going to talk to you about the problem that has been talked. Tim Caswell talked about it. Actually, the next speaker, Tom, is going to talk about the same problem that exists in kind of this non-blocking environment. I have just one hack I'm going to share with you that can make your code a lot easier, that you can apply, that is very functionally oriented, and I'm going to show you what you can do with that hack. So, what is the problem? Look at this. Here's the current schedule for our block right here. And if you guys could go to jsconf.eu/2010/speakers.html and search for spaghetti, you'll get 2 hits. The presentation before mine and the presentation after mine. And I, too, am going to talk about spaghetti code. So, but if they are non-blocking, what looks to you like this actually runs like this, right? Which is why non-blocking code is the position absolute of JavaScript. All of a sudden, you had no concept of time. It was just order. But now we have this concept of time. It's just like with CSS, everything, no 2 blocks could occupy the same space, but all of a sudden you have z-index. And it's like just like for, CSS folk, that's kind of one of the things they get around. I feel like non-blocking is the same thing for us. So if the code don't block, you must call, it rhymes in German, in a German accent at least. And so basically, I feel like developers have 2 choices. You can take the blue pill or the red pill. You can abstract it or attack it with this kind of code. And so to kind of update to a more modern movie reference, you can have someone else do it for you, or you can do it yourself, right? And so let's talk about these 2 choices. Abstracting it. There are a bunch of things that people use. I'm not one of them, but basically, if you want to maintain this illusion that you live in this synchronous blocking world, there are libraries that will help you do that. But it's not easy, because you really have to rewrite this code. And so the guy who really explained it best, does anyone know who this is? It's Jeremy Ashkenazi. He is the guy who wrote CoffeeScript, which is awesome. And so there was actually a branch of CoffeeScript that called defer, and they basically let's have this thing called defer. It's keyword, and then we'll rewrite your CoffeeScript into code that actually handles it. And to you, it's just totally, you don't actually see all this mess that's happening. And Jeremy said this. He basically says you can't do it and maintain the one-to-one mapping. You don't want to be debugging someone else's machine-generated code. That's no good. And so he basically gave that branch the bots, the X. Because he looked at it and he took a function like this, and then basically when it was rewritten by stratified JS, it would turn into this, right? And so you don't want to debug that. I don't want to debug that. So I think the best option is to take the red pill and attack it. But then, you get this, code that turns into this, and that's spaghetti code. Unless you're a German JavaScripter, you would call it Spätzle code. Or if you're Tom, you call it a pyramid. I like to refer to it, given the current movie reference, as a Cobb salad. And so we're going to try to see how we can avoid that, because the abstractions with these generated frameworks are leakier than this venue in the rain. You know, you have this pre-compilation step, which is annoying, because then you're not dealing with your actual code, and that makes debugging really hard. But then, if you do it yourself, then you get these like nested callbacks, you have all the shadowing, and worse. So we want to kind of avoid that by using functions. Functions are going to save us here. So here's the hack. Ready? Take a look at this code. It's the same code you saw earlier. We're going to get rid of those because we don't need those. I don't need those. If you use lint, you will. But all right, so are you ready? Here it is. One hack. We're not going to change any characters on the screen. Here's all we're going to do is this. That's it. You're done. All right, cool. Did you miss that? Ready? Here it is again. Oh! Isn't that awesome? What happened? All right, well, we accidentally the whole execution stack. Right? Instead of letting the interpreter decide when stuff would get executed, we did. Right? And so let's take a look at what actually happened there. People know what's going on here when they see this code, right? Well, basically, the first set of parens we don't need. That's the function that gets called, right? Everything after it gets passed to that function, right? So the setup, that's like another function reference, that gets passed, and now you could have a closure that would return, in this case, a function. Init s, because it represents the state of that function being called after it was given that argument, right? So we can just keep doing this, right? We can just load this thing up with all of these functions, right? All right, so now let's talk about this thing right here. What is that? Well, it's seen all the execution stack after it, and it could potentially resume evaluation when invoked. What do we call that? Anyone? What do we call that? It's called a continuation, exactly. So basically, a continuation is basically you're running some code and you stop, right? And you have some sort of object that you can then reify and then continue execution. So we just created a continuation, and we did it using streams, which is kind of cool. We streamed all of those functions into this one function. Streams are very important, as you know. Malta works on, Streamy. Streams are pretty important. I think they're going to be a pretty important data type, especially for Node going forward. If you look at all the work in Node, it's all around streams. So. But streams, I mean, they're not an easy concept for everyone, but we've seen them before. Does anyone know what we fill these two spaces in with? Any guesses? Beer. Streams are to beer as arrays are to more beer, yes, right now. Streams are to time as arrays are to space, that's it. A stream is an array in time. Instead of accessing it in memory in space, you get it in time, right? So it's like literally just a different dimension, just like we had the idea of, CSS position absolute is space, whereas non-blocking code is time. It's the same thing. So these two look very, very similar, and they should, because in the first init, you're passing it basically an array. It's an arguments object, I know, but it's basically an array. And the second one, you're actually sending things to it multiple times as long as it returns something to keep listening, right? So what's the difference between these two things? Well, arrays are fast, streams are small. When you usually have some sort of framework that kind of abstracts it, the first thing to go in like a framework that does like web stuff is streams. They just buffer everything, right? So what ends up happening is you have to handle these huge bodies. That's bad for memory. So arrays are fast because you have access to everything that's already in memory, but streams are small. Small is important because small means a small memory footprint. So arrays are eager. Everything has to be there at once. Streams are lazy. You can kind of get it over time. Whether run is called immediately, synchronously after, whether cleanup is called immediately, synchronously after run, or like 5 minutes later does not matter, as long as that state is preserved. Arrays are sync, they're all there. Streams are, but they do not have to be, but they can be async. So that's kind of an important thing. And that's it, that's the hack, okay? So what's the upshot from this? Well, I've developed a framework called Fab, which basically takes care of that kind of exploits this kind of streaming. And so basically, it loves functions. It's a functional framework. And so it's basically originally modeled on jQuery. This is not true anymore, but basically what I looked at, jQuery is traversing over the DOM. We have routing over URLs. Yes? Oh, really? Sorry. All right. Anyone, any questions? Thank you for that. I appreciate that. Any questions? I feel like I've been scolded by my German school teacher. My mom told me to slow down too. It's a tragedy. Where you would traverse over a DOM, you route over URLs. Where you would manipulate A DOM, you respond to calls to your web server. Where you would have UI events, you have HTTP verbs. So I'm like, that's kind of a cool map. So let's take this UI, this DSL that you guys already know, probably, unless you're Rebecca, and then you would replace it. Just kidding, it's a joke. You would replace it with this. It's like these are kind of the same thing, right? And so I was like, well, that's kind of a cool thing. And so that's how Fab started. The reason, actually, Fab is find and bind, because I basically co-opted those two jQuery methods. So that was it. All right. So, but jQuery wasn't really cutting it for me. It didn't really match, right? jQuery, you have this huge DOM. Everything is synchronous. You know, in terms of manipulating the chained. I like the chain, but I didn't like the synchrony. So I got inspiration somewhere else, and that was Unix. So Unix chaining basically looks like this, right? So I'm not a Unix guy. I'm just kind of faking it here. But the idea is that, you know, every little program you have has an input and has an output, right? And so that's really cool for frameworks. If you look for the frameworks that are really cool, like for example, look where Rails went. Look where Sinatra went. They all went to Rack, right? Because Rack is good for middleware. Everyone's going to middleware. It makes sense. The thing about Fab, the entire thing is middleware. You saw those streaming functions? Fab uses that. And those basically, every function, every app is middleware that operates on a stream. Even the app definition itself, there's no difference between an app and a response. An app is just a response that hasn't been evaluated completely yet, right? So you stream things. Some of those things are functions that you would then call later. So there were a bunch of things. How am I doing on time? Am I doing okay? 12:30? Sorry, 12:15? I'm doing okay. I want boilerplate. I want to keep it as small as possible. I want it to be natural, no compilation step. I want it to be JavaScript. I don't want it to write some other language, some Franken language. I want it to be consistent. I don't want, you know, like kind of different classes of things. I want everything to be a function. I want it to be clean, no global pollution. Unambiguous, no mandatory magic. The first thing frameworks do to solve an abstract away problem is give you all these like splay methods everywhere that make it really easy to pick up but really hard to scale. I want to avoid that. So if there's magic, it's yours. No shared state. That's obviously a functional programming thing. Can't be synchronous, of course. Very little side effect. Egalitarian. I don't like the system of, well, there's apps and then there's your plugins. I want those all to be on the same level. And I want it to be composable. So you should be able to create apps, and those apps should go into other apps. So Fab is two things, okay? The first thing is Fab is a pattern. Every single Fab app, every single one, looks like this. Okay? So take a while for this to sink in. It's really not that hard. Basically, the idea is you have a function. Every function, the first thing it does, it takes a callback. That's the function it's going to write its answer to. Okay? Then it returns another function. That is going to listen to everything that comes subsequently, right? Until it hears nothing, right? And then it's like, okay, I'm done. So usually what happens at this end step you see right there, it'll actually return the original write function passed in first, right? When it sees the end, it gives control back to whatever was before it. Does that make sense? The idea here is you're using callbacks to pass data asynchronously, and you're using return to pass control synchronously. Right? So you're passing control synchronously. And so Fab is also a library, right? So it's basically a library of just it's a flat library. If you go actually to the GitHub repository, it's literally just a flat list of all of these functions. There's no hierarchy at all. Each one could be put anywhere. So what are these, you know, it's these libraries. So I really like this Unix philosophy of keeping it small. So literally, after gzipping, which, you know, only is to show not so much how small it is, but I think it's the most canonical way of comparing two libraries. This is the size of each of these functions, each of these apps. I mean, this is one of the few frameworks that you actually might even, you know, enter JS1K. Probably not. You would probably have to take a bunch of stuff out of it. But everything is very small. And so I guess the only thing left to do, given that I didn't complete my slides entirely, is to show you how it works. And so there's going to be some live coding. And we're going to build an app right here. So I'm going to roll up my sleeves. And we're going to switch over to Text Wrangler, because that's how I roll. Any questions while I'm rolling up my sleeves? No? All right, cool. Let's get out of this keynote hell. OK, cool. Here is a text editor. OK, cool. So what does it look like? Well, it looks like this. Everything is an app. Every app is on the same level, including your app. You know, like a lot of times you would have a library, and you would have an app. And the app requires the library, and it does its stuff. The thing is, your apps are also libraries, right? Everything's middleware. So basically, everything looks the same. So we're going to use this. Yeah, I'm sorry, I should really fix that, shouldn't I? Everything here, on my screen, it's like weirdly fat. Like I'm looking at some, whoa, music, video. Hold on. Is that okay? Yeah. That's probably a little small, but we'll see where it gets us so far. Okay, cool. All right. So you've seen this pattern before. I'm not a huge fan of this, to be honest. Function. You might be. I'm sorry. All right, cool. So exports, because we're going to basically co-opt. Exports should be asynchronous. It should be a function. It shouldn't be assigning something. Honestly, not a fan, but whatever. I will yield to that system and implement it myself. So basically, we're going to do this. We're going to return exports, and we're going to call it with our app. What are we going to do? Well, it's just going to say hello. Okay, cool. That's our app. All right. You can really start small. It's not a huge thing, right? So all this app gets is this exports thing, and it just, so basically it gets a pipe, and you write to it. Okay, cool. So if we ran this, hello, I don't want to see that. Where am I? Sorry. Okay, we just ran an app, all right? You see what happened? Yay, that's cool, right? So Fab is not necessarily a web framework. Yeah, thank you, appreciate that. Fab is not necessarily a web framework, right? Web is just a part of it. So let's actually do some web. And to do that, we gotta import some stuff. And again, same thing. I don't think require should be synchronous. I think require should be asynchronous. But you know, a lot of people who are much smarter than me disagree, so that's okay. But I'm gonna do it myself. So basically, you get two things here. Actually, I lied. One is imports. Imports basically wraps required, but it makes it asynchronous. I don't want asynchronous necessarily because I need it to be somewhere else in Bangladesh when I get the file. I just want to use one API for everything. That's why I believe in asynchronous. This thing is really, I feel like a Backstreet Boy. All right, cool. Almost, you almost had me. So let's import stuff. We're going to use function, not function this time. All right, cool. So let's put this in here. Yay. Okay, so that actually does the same exact thing. We just imported nothing in this case, right? So now we're going to import, let's see, well, what do we need to run a web server? We need like a listener? Well, first of all, we need to actually run this function. This actually is not running. It's just literally sending something, right? So we're going to need something called run. We're also going to need a node listen, right? Because basically we want node to be able to listen to stuff. This is a huge hack, by the way. I love this. Do you guys know what's going on here? I'm basically taking your call, and this is optional, so don't get too upset about it. I'm basically taking your callback and two-stringing it and sucking out your arguments. And looking at those strings and then going to require and getting it myself. But that's totally optional. After, right here, you could put arguments and do it explicitly, but I like this way. So, okay, cool. So now what we're going to do is we're actually going to return run. And then, so run basically just evaluates a stream. And so the first thing we do here in the stream is we do node, oops, sorry, jQuery, sorry. Node listen. We're going to listen on a port, my favorite port. Okay, yeah, sorry. And then actually here, so the thing is, we don't want to export it, so we're actually going to leave. So run, it's just another function. The first thing it takes is its callback, right? But we don't want to actually send to the standard out, so we're actually going to leave that blank. And then so we have this thing here, and this is kind of cool because it looks like markup, but it's not. It's pure JavaScript. And so we're going to run this. Get there. Hello, yay, web server. Oh, stop, you guys. All right, cool. And this is actually going to get a little bit messy. So I think what I'm going to do is put this down here. This is for Isaac. Thank you. All right, cool. So, right. So we're gonna pull some more stuff. So we have all this library of these tiny functions. So what's the first thing you want to do in a web framework? We have with web servers just returning hello. What else do we want to do? Yeah, like a root. Okay, cool. Well, we have that. It's a tiny app. It's called root. Thank you. Check is coming. And so let's root. So what does a root look like? I don't want to create, now a lot of, again, one of my complaints about these web frameworks is they all create like their own special syntax. We have a syntax for matching strings. It's called regex. Okay, we're going to use that. And so here's what I'm going to do. I'm going to route, and I'm going to do it on, this is going to have to this is going to have to match the root path. All right, cool. All right. That's a block. Okay? And then if it doesn't match, we will return not found. And that will be status 404. Okay. All right, does everyone understand what's going on here? All right, should be pretty easy. It looks to us, I've indented this. It looks like it's indented. It's not Python. Indentation is meaningless. Each app is responsible for knowing what happens. Here's what root does. When root is called, it's like, give me a stream, give me a stream, give me a stream, right? Actually, I did this wrong. I apologize. It's like, give me a stream until it sees stop. This should be out here, right? Until it sees stop, and then it says, okay, everything that I just got in that stream, if it matches, I'm gonna reify that stream. If it doesn't match, I'm gonna reify the next stream. So if this worked properly, what should happen now when we reboot this thing, is that I still get hello, but if I type some weird path, I get not found. Okay? Is that cool? Does everyone get that? Oh, really? Really? All right, do you want to see the source? It's really not that bad. It's really, yeah, the source is not so bad. So what does root do? All right, well, basically this is it. We have something called stream. Stream just basically takes a stream and saves it. You can replay it later. So get a stream, we're going to call that yes. Get another stream, we're going to call that no. Return an app, right, which is just a function that gets evaluated that looks for that URL. If you have a pattern in there, it'll capture that and store that in the head, like head.url.whatever. And if not, it'll actually just keep, if it doesn't match, it'll go to the second stream. So going back here, I guess we have 5 minutes left. So that worked. All right, cool, so we routed. What else do we do in an app? Well, let's, for example, if we wanted to say like hello, we wanted to say like a name, like if you want to say hello name, you could capture something there. And so all that would look like is basically, how do I do this? Actually, you know what? Let's do HTML first. HTML. Actually, you know what? I'm going to slide back because I only have 5 minutes left. I'm going to tell you about HTML. I have an HTML, ideas about HTML. Templating is like literally the biggest thing in the Node modules. It's like the biggest list after databases, right? It's huge. There's like a jillion templates, and they all do it differently. I'm not a huge fan of any of them, so I created my own. It's called Fab Markup Language. And so, all right. So if you created a template, what would it look like? Mustache is awesome. I really like Mustache. I like, you know, the power of resigs. What's it called? But basically, I think it maps pretty well, okay? We have HTML. We have JavaScript, right? So, like, are you with me? All right, comma, right, open, with, okay, right, sure, go, okay, sure, close that, and get your contents, and then close that, okay? These are identical. More or less identical. Okay? That's a win, I think, because it's like, you don't have to learn anything. I don't have to learn that, like, you know, % sign means this, and it's like, I don't want to reinvent Perl in a template engine. And so basically, what your HTML app looks like is this, right? Take a pipe, write the open tag, push everything through as long as there's data. When data ends, right, push the close tag. That's it. It's really easy. There's a special case in this that I'm not showing here for, I'm sorry, like your argument, what do you call those? Attributes. But that's basically it, you know? Right? Write the div, return this function. If there's data, write it, return read. We're going to loop back. When data ends, write the div. Okay, cool. And so basically what we can do here at this point is import HTML, right? And so, and here's, you guys, this is where you might depart with me. All right? You see what we're doing here? It's a namespace. All this thing is a namespace for each element. But what that means is we can do like really cool stuff. Like, check this out. Actually, what we can do this, we can actually put this around the root. We can put this here. So we can go, you know, HTML, body, you know, ID equals, you know, JSConf. And then put this here. Actually, hold on, what do I want to do? I want to put this here too, right? We want this not found to be in there. So basically, instead of having a router in front of your app, your router is your app. Your router is just another app in this chain. You can route anywhere. And I mean, of course you can abuse this and your code can look like PHP, but you don't have to. I mean, you could put it wherever you want. But the idea is that it's super easy to get started. Oh man. Get there, please. Whew, there it is. Right, and there's our not found. Okay. HTML, and again, this entire thing is asynchronous. This thing could sit forever, okay? Check this out. How much time do you have? Am I done? I got 2 minutes. Check this out. I have something called sleep. What do you think this does? Is it synchronous? Who thinks it's synchronous? Ah, you guys know me so well. All right, cool. Let's put it right here. I want to sleep for a second. That's pretty dangerous, right? But no, what does sleep do? As soon as it's called, it gets a stream of everything that's left, and it saves that. And it's like, it does its thing, and when it's over, it just replays it, right? And you can do that because all the state in your application is in this chain. That function knows exactly what's happening, and that's the benefit of using the style. And so, if this works, I haven't hit one error yet. I've been doing it for a second. This should take a while, right? And so actually, you can keep doing that. So I can just go like, bam, 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 bam. And then what I can do is actually, let's see if this works. I can go over here and go do this. I hope this works. Oh, I'm sorry. Did it? Oh, I didn't. Yeah, I forgot to restart it. Right. All right, cool. Get there. Right? That's for free. You didn't have to do any sort of marshalling of anything. Like, that's kind of cool, right? It's just as long as you can, control yourself enough to conform to this kind of spec, stuff like that is easy. And that, oops, I don't want to do this slide again. Fast forward through this is it. Thank you. It is vapor compliant. Thank you.